Welcome to the video lecture on Moment of a Force, brought to you by Formation Professional Private Limited. As we all know, when a force is applied to an object, it can cause several effects. A force can cause an object to accelerate. It can even cause an object to change its shape or size. A force can also cause an object to turn. We call this the turning effect of a force, or more scientifically, we call it the moment. Now let's take a look at the diagram here. We have the pivot, denoted by this orange circle, and then we have a green color horizontal rod attached to the pivot itself on one end. When a force is applied in the upward directions, the distance d forms the perpendicular distance from the pivot to the force. To calculate the turning effect of this force about pivot, we use the formula of force multiplied by the perpendicular distance, and the SI unit is Newton meter. In general, moment has got two directions. One is the anti-clockwise directions, so that when a force is applied in upward directions, the whole structure tends to rotate in the anti-clockwise sense. And the other directions is the clockwise directions. This is when the force reverses its directions downwards, so the whole structure tends to rotate in the clockwise directions. Now, usually moment calculations are quite easy. You just take the force, multiply by the perpendicular distance, and there you get it. However, the challenging issue in moment calculations is usually on how to identify the perpendicular distance from the line of application of the force to the pivot. And many students tend to identify the wrong distance. Okay, let me illustrate my point by looking at some examples. Example 1. We have this circular object, roll and hit upon this obstacle. So the point of contact is at this point here. In order for the object to start rolling up the obstacle, it has to actually roll and rotate about this point, which we call it the pivot here. So this point, I will call it the pivot. So if I apply the force at the tip of the object on top, what should the turning effect be in order to rotate this whole object up and overcome this obstacle? So we have to identify the correct perpendicular distance. So take note, this is not the correct perpendicular distance. Right? The reason is simply because this distance does not form a 90 degree with the line of actions of the force. So where is the perpendicular distance? The perpendicular distance is denoted by this d here, where it forms the distance of angle 90 degrees from the line of actions of the force to the pivot P. So this is the correct distance. Now let's take a look at example 2. Now in this case, I have a force which is slanted towards up left about the pivot P. So now the question again is, how do we calculate the moment of this force? By identifying the correct perpendicular distance. Now take note, the perpendicular distance in this case is not the length of this supporting rod. It is the same reason as the previous example. This angle has to be 90 degrees, whereas in this case, it is not 90 degrees. So, the distance of this rod is not the perpendicular distance that you can use to calculate the turning effect of this force about the pivot. So where is the perpendicular distance? This is the perpendicular distance, where the distance d forms an angle of 90 degrees with the line of actions of the force to the pivot. Let's look at the last example 3. So this last example, there are two forces acting on this structure. So one force is the horizontal force acting at the tip on top. The other one is the weight of the whole structure acting down somewhere in the middle. So let's look at the first one, the first force here. how do we identify the turning effect by looking at the correct perpendicular distance? First of all, you have to understand that when this force is pushing the object at this point, the object will end up with a supporting point here when it's just about to topple. So this is the last point of support, which we will call it the pivot. So where is the perpendicular distance? Now, if a student try to draw like this is not the correct perpendicular distance. So where is the perpendicular distance? The perpendicular distance, again, is the distance which the line of actions of the force forms a 90 degree with it, with respect to the pivot. So this is a 90 degree, and this is the correct perpendicular distance that you can use to calculate the turning effect of this force about this point. Similarly, if you want to calculate the turning effect of this weight about this point, you must also identify the correct perpendicular distance. Now, if a student try to draw it this way down, a straight line, assuming, this is not the correct perpendicular distance, right? Because this is not 90 degrees. So where is the perpendicular distance? The correct perpendicular distance is from here to this point, from this length of the action to here. So, to illustrate my point, the correct perpendicular distance due to the weight to the pivot P is this distance d2. I hope the above 3 examples have highlighted the necessary information you need to identify the correct perpendicular distance from the line of actions of the force to the pivot so as to ensure correct calculations of the moment. Thank you for your attention. Have a nice day.